Hi everyone, I'm Sona. This is my peer graded assignment on combined cycle power plant. As part of this, I am trying to develop a predictive model for estimating the electric energy output of combined cycle power plant. This plant utilizes gas turbines, steam turbines, and heat recovery steam generators in combination to generate the power. As we all got one CSV file with some existing data, we'll be using that. The scope of the modeling exercise involves some data understanding, modeling. I would do feature selection, algorithm selection. I'll be training the model with part of the data and then evaluate the effectiveness of the model being or algorithm being selected. All right, there are four independent variables: ambient temperature, exhaust vacuum, ambient pressure, relative humidity, and one dependent variable called net hourly electric energy output. So going back to Python, I imported the necessary packages and then read the CSV file. As you can see here, the variables AT, V, AP, RH, and PE are here. There are 9,568 rows. All right, let's go ahead and start visualizing the data. I'm starting with the dependent variable, and let's see. It seems to be continuous data and bimodal in nature. I am going to look at each of the other variables also just to know that is also bimodal and seems to be continuous. Again, distributed. Again, seems to be continuous in nature. All right, seems to be distributed. And the last one, RH. All right, again distributed like this. I took a quick look at the data. I see no blanks as such in the entire data set. I filtered and checked as well. Everything is numeric. So that's it. From visualization of the actual data itself. No pre-processing required at this point. Okay, the next step before we go ahead and do feature selection is to quickly check a correlation between the variables, independent and dependent variables. I'm going to do a quick correlation check. And as you can see here, AT and V have got very high correlation to the dependent variable PE. APRH seems to be less so. I will ignore PE to PE, it's the same variable. I'm going to also visualize with a pair plot. Let me run this. Wow, look at this. AT and V seems to have a obvious linear regression model, whereas AP and RH seems to be distributed all across, not as much of a straight line as you can see here. At this point, we have now identified that our output dependent variable is continuous in nature, and we have seen even with the data visualization that there is a linear regression kind of a relationship. So the next step is to split the data that is given to us into a training set and an evaluation test set. I would then run linear regression model with the data with a various combination of variables, input variables, and check how the fit works. All right, the next step here is to split the data into training and test. What I have done is we have chosen linear regression based on the output variable being continuous, and then we now will be doing a combination of variables to see how the model performs with various combinations. As you can see here, first what I did was did a linear regression model with just AT, V, AP, and RH, all four variables. The score that came out was that it was at 93.5%, very effective model. Usually industry standard, what people take as good model is when it comes to around 70 to 90%. This one is an extremely good model when we use all variables. For the sake of completeness, what I did here is that I did a combination of various variables and see how the model performed when we removed just RH, for example. At that case, what we found out was that it was 92.5% or 92.3%. Didn't make much of a difference when we removed that variable. Again, that means that relative humidity is not effective in this model. Don't really require it. I then took out the next one, which is AP, and then ambient pressure, and found out that that too actually did not make much of a difference. It gave the model a score of 92% when we are just working with AT and V. Now, I also did other combinations and found out that the model works perfectly fine when we use only AT as a variable. It gave a 90% score when we used only AT. When we use only V, then it gave a 75% score, which is horrible, which is not too bad, but what we can do is we can just select ambient temperature to predict this model pretty much. Ambient temperature with a vacuum, exhaust vacuum together is the best predictor as far as we can see here. I also tested the negative scenario of AP and RH and found out that that gives the poorest score. In conclusion, we did the following. We actually went through the data, looked at the data to see whether it was continuous or discrete. We found out that the data was discrete. We identified the output and the input matrices. We identified and visualized the data to see what pattern the data came in. We also looked at the correlation between the input and output variables and found out that linear regression was the algorithm to be picked. We ran a few models with the combinations of variables, input variables, and determined that the most effective input variables, which gave us the best model, was ambient temperature and exhaust vacuum. Thank you for listening. Until next time.